Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Welcome everyone. Today, we'll delve into the fascinating world of generative AI in planning tasks, examining its challenges and exploring innovative approaches. Our focus will be on understanding the limitations of generative AI due to overconfidence and inefficiency. We'll also explore fast downward, a more effective approach that emphasizes specific tasks and cost-effectiveness. Furthermore, we'll discuss LoRA-Augmented LLMs, specialized models that combine the strengths of traditional methods and generative AI for enhanced planning capabilities. Throughout our discussion, we'll highlight the importance of cost-effective strategies, as increasing compute budgets does not necessarily lead to better outcomes. We'll conclude by considering how future AI development may balance traditional methods with advancements in generative AI, prioritizing efficiency and effectiveness over size. Join us as we unravel these key ideas and engage in a thought-provoking discussion. Hello everyone. It's a pleasure to engage in a discussion about generative AI and its capabilities. To set the stage, could you explain the importance of planning tasks within the broader context of artificial intelligence and how they have traditionally been approached?
Planning is like mapping out treasure hunt. Imagine you have a big, complicated map with many paths, some leading to treasure and others to dead ends. Just like a treasure hunter needs to think carefully about which path to take, AI also needs to plan to solve complex problems. Planning helps break down big challenges into smaller, manageable tasks, making it easier to find the best solution. Traditionally, planning in AI has been a difficult puzzle to solve. Researchers have spent a lot of time trying to teach machines how to think ahead and consider different possibilities, similar to how humans can weigh options before making a decision. Unfortunately, many of the latest AI models, like large language models, struggle with planning. They often treat problems like a guessing game, rather than carefully considering all the possible paths, which can lead to poor outcomes. In summary, planning is important because it allows AI to navigate through challenges thoughtfully, but it remains one of the hardest skills for AI to master.
Thank you for that insightful analogy. It highlights the complexities involved in planning tasks for AI. Given the challenges that large language models face in this area, could you elaborate on the specific inefficiencies and overconfidence issues that these models exhibit when tackling planning tasks?
Large language models, LLMs, can be like a confident student who just doesn't quite understand the homework. They often come across as very sure of their answers, even when those answers are completely wrong. This overconfidence can lead them to present plans that are unworkable or silly, making them appear more capable than they really are. One major inefficiency is that these models struggle significantly with complex planning tasks. They might seem to perform well on simpler tasks, but as soon as a plan becomes more complicated, their accuracy plummets. It's as if they're trying to solve a giant puzzle, but give up after just a few pieces. For instance, when a task involves many steps, like moving blocks in a specific order, the model can get lost and end up producing a lot of unnecessary and confusing information, costing time and resources. Moreover, when faced with problems that don't have a solution, these models often fail to recognize that fact. They only acknowledge when a plan is unsolvable a small percentage of the time, which leads them to waste effort and create elaborate but ultimately pointless plans. This creates a frustrating cycle where they sound intelligent while delivering poor results, almost like a skilled actor playing a role without really understanding the script. In summary, while LMS can be very convincing and seem to improve on the surface, their planning abilities are hampered by inefficiencies and overconfidence, resulting in flawed conclusions and high costs.
That's a compelling explanation of the limitations of large language models in planning tasks. In light of these shortcomings, the study introduces the fast downward approach as a more effective alternative. Could you clarify how fast downward operates differently from LMMs and why it outperforms them in planning tasks?
Fast downward operates like a skilled navigator using a clear, specific map for a treasure hunt, while large language models, LMS, are more like someone trying to guess the treasure's location without any map at all. Fast Downward uses a search method that focuses on finding the best answer by exploring potential paths step by step, ensuring it can tackle complex planning problems efficiently. One of the key differences is that Fast Downward is designed to be small and task-specific. This allows it to work effectively, without the overwhelming size and complexity of LMS, which are like giant encyclopedias filled with information but poor at finding the right path in complicated scenarios. While LMS can easily get confused and generate a lot of unnecessary information, Fast Downward stays focused on its task, resulting in better performance. Additionally, Fast Downward is much faster and cheaper to run compared to LMS. It can solve planning tasks with much greater accuracy and efficiency, even outperforming the latest models that claim to be state-of-the-art. In essence, Fast Downward is like a trusty compass that guides you directly to the treasure, while LMS often end up lost in a maze of confusing ideas.
That analogy really clarifies the distinctions between Fast Downward and large language models in planning tasks. The study also suggests that specialized generalists, such as LoRA-Augmented LLMs, may offer a better approach. Can you explain what LoRA-Augmented LLMs are, and how they might improve planning capabilities compared to traditional LMS?
LoRA-Augmented LLMs can be thought of as specialized chefs who have trained extensively to master specific dishes, rather than generalists who can cook a little of everything but may not excel in any one area. These models are designed to be fine-tuned for particular tasks, which gives them an edge over traditional large language models that are more like a buffet with a wide variety but little focus. The improvement in planning capabilities comes from this specialization. By honing in on specific tasks, LoRA-Augmented LLMs can understand the nuances and details better, allowing them to make more accurate and effective plans. This is crucial for complex problem solving, where a nuanced understanding makes a big difference. Additionally, because these models are not as large or resource-intensive as traditional LMs, they can operate more efficiently and cost-effectively. This means that while they are finely tuned to perform well in their specific areas, they also avoid the pitfalls of the larger models that struggle with planning and can waste resources on irrelevant information. In summary, LoRA-Augmented LLMs represent a promising approach that combines the strengths of specialized knowledge with efficiency, potentially leading to better planning outcomes compared to traditional LMs.
That's an excellent breakdown of LoRA-Augmented LLMs and their role in enhancing planning capabilities. The study also emphasizes the importance of considering costs in AI development and challenges the assumption that merely increasing compute budgets leads to better outcomes. Could you elaborate on why this perspective is significant and how it might influence future AI research and development strategies?
The perspective on costs in AI development is significant because it challenges the common belief that simply pouring more money and resources into bigger models will automatically lead to better outcomes. It's like thinking that if you build a bigger and fancier car, it will always drive better, even if the engine is poorly designed. This assumption can lead to wasted resources without guaranteed improvements. By focusing on cost-effectiveness and measurable performance, researchers and developers can prioritize strategies that yield real results rather than just following the trend of building larger models. This shift could encourage the exploration of more efficient methods, such as fine-tuning specialized models like LoRA-Augmented LLMs, which can deliver better performance without the hefty expense associated with massive models. This perspective might influence future AI research to value intelligence per watt, meaning researchers could look at how much effective work a model can do compared to the energy and resources it consumes. Such an approach could lead to innovations that prioritize efficiency and effectiveness rather than size and power alone. Overall, Questioning the assumption of bigger is better can steer the AI field toward more sustainable and practical development strategies, ultimately leading to smarter, more capable AI systems that serve real-world needs without unnecessary costs.
That's a thought-provoking viewpoint on resource allocation and efficiency in AI development. Considering the ongoing challenges and the potential for innovation, how do you see the balance between traditional planning methods and advancements in generative AI evolving in the future?
The balance between traditional planning methods and advancements in generative AI is likely to evolve into a more collaborative relationship. Traditional planning methods, like fast downward, have proven to be effective and efficient in tackling complex problems. In contrast, generative AI, particularly large language models, brings creative and flexible approaches to problem solving, even if they currently struggle with planning tasks. As researchers recognize the limitations of LMS, there may be a shift towards integrating the strengths of both approaches. Instead of relying solely on large models that require massive resources and often yield flawed results, future AI development could focus on combining the structured, reliable methods of traditional planning with the adaptability and context awareness of generative AI. This integration could lead to specialized models that can handle planning tasks more effectively. For example, using insights from fast downward or similar methods alongside refined generative capabilities could result in AI systems that are both powerful and practical, addressing the shortcomings of each approach. Ultimately, this balanced evolution would aim to create AI systems that are not only intelligent, but also capable of making wise and feasible plans. By moving beyond the notion that bigger is always better, the AI community could foster innovation that prioritizes effectiveness and efficiency in problem solving.
That vision for the future of AI development sounds promising, emphasizing the importance of collaboration between different methodologies. To wrap up our discussion, could you summarize the key takeaways regarding the limitations of generative AI in planning, the potential of specialized models like LoRA-Augmented LLMs, and the significance of cost-effective strategies in advancing AI capabilities?
Key takeaways regarding the limitations of generative AI in planning, the potential of specialized models like LoRA-Augmented LLMs, and the significance of cost-effective strategies are as follows. 1. Limitations of generative AI in planning. Large language models, LMS, struggle significantly with planning tasks. They tend to generate elaborate but often impractical solutions and fail to recognize when a plan is impossible. Their overconfidence can lead to poor decision-making, which highlights their inadequacies in effectively tackling complex problems. 2. Potential of specialized models. Specialized models such as LoRA-Augmented LLMs represent a promising direction for AI development. By being fine-tuned for specific tasks, these models can combine the strengths of traditional planning methods with the flexibility of generative AI, potentially leading to more efficient and effective planning solutions. 3. Significance of cost-effective strategies. The emphasis on cost-effectiveness in AI development is crucial for sustainable progress. Simply increasing computational resources does not guarantee better outcomes. Instead, focusing on intelligence per watt can help prioritize methods that yield significant results without excessive costs. This perspective encourages the exploration of more efficient, specialized models that can deliver high performance while minimizing resource use. In summary, the future of AI planning may benefit from a blend of traditional methods and specialized models, while remaining mindful of the costs associated with development. This balanced approach can lead to more reliable and effective AI systems capable of handling complex challenges.
Thank you all for joining us today. We've delved into generative AI's challenges in planning tasks, exploring fast downwards efficacy and LoRA-Augmented LLM's unique capabilities. Remember, cost-effectiveness is crucial. larger compute budgets don't always equate to better results. As AI evolves, we'll likely witness a delicate balance between traditional methods and generative AI advancements. We must prioritize efficiency and effectiveness over sheer size. Thank you again for your participation. Let's continue these discussions and work towards a future where AI empowers us in a responsible and meaningful way.